Graphs of linear inequalities. In this lesson, we will learn to solve a linear inequality in two variables by graphing, and then solve a linear system of inequalities by graphing. Now let's discuss how to solve a linear inequality in two variables by graphing. Your first question might be, what is a linear equality in two variables? Well, let's think of a linear equation. A linear equation, y equals mx plus b, is considered an equation in two variables because we have a y here and an x here as our variable. Now, if we replace the equality symbol here by an inequality, say for instance, less than or equal, or greater than or equal, or just strictly less than or strictly greater than, the resulting expression is an inequality in two variables. So when we talk about solution of an inequality in two variables, we will think of a region. Because if we have an equation, if we just have an equation, for instance, y equals mx plus b, the solution here is a point. But if you have an inequality, the solution here is a region, because it will consist of collection of all points that would satisfy this inequality here. And so again, if you want to solve a linear inequality in two variables graphically, you first have to graph the line y equals mx plus b, and then you think about the region on either side of the line where any point in the region makes the inequality true. You do that by getting a representative point on a region and see if it satisfies the given inequality here. Now, once you find the region that makes the inequality true, you shade it, and that is our solution. For example, let us solve the inequality here, y greater than or equal to 2x minus 5 by graphing. So to do this, let us start by graphing the line y is equal to 2x minus 5. So to graph a line, you just need a point on the line. So let's start with the y-intercept. So, or you could actually make a table. This would be your x and this is your output y. So you could start by letting x be equal to 0. So if x is equal to 0 here, we have 2 times 0 minus 5. That gives us negative 5. This is the y-intercept. Then another point, say for instance we have y, you can have x equals 1. So if you plug in 1 here, so you have 2 minus 1, 2 times 1 is equal to 2 minus 5 is negative 3. So now you have 2 points, and then you just have to graph those 2 points. So we have 0, negative 5. So this is 0, negative 5. And the other point is 1, negative 3. So when x is equal to 1, y is equal to negative 3. Negative 3. And since we know this is going to be our line, and then we can just have, or we can also get a third point, or just compute for the y-intercept, because we know that, or the x-intercept, we know that it will cross the x-axis. So we do that by letting y be equal to 0. So if we have y is equal to 0, we have 2x minus 5. And then you just have to solve this equation here. You transpose 5 on the other side. You have 5 is equal to 2x. Divide both sides by 2. You get x is equal to 5 over 2, or x is equal to 2.5. So we have here 2.5. That is our third point. Then the next step is to just connect all these 3 points. So when you connect the points here to graph a line, you go back to the inequality and check if you have the equality symbol. Since you have the equality symbol here, then the graph is a solid line. So we have a solid line that would connect all the 3 points here. This is our line. After that, you can extend this, all right? Then after that, you can shade the region that would satisfy this inequality here. So we have y greater than or equal to 2x minus 5. So we are going to decide whether this region here, the upper region or the lower region. So how do you do that? You just get a point on this region here. So for instance, let us consider the point 0, 0. So if we have 0, 0, you can replace y equal to 0, and then if we replace x by 0, this would be 0 minus 5, and see if this inequality here holds through. So is 0 greater than negative 5? Is 0 greater than negative 5? The answer is yes. 0 is greater than negative 5. So therefore, this point here is on that region, and then we say since this one is satisfied, then we will say that this region here, the upper region here, let's highlight that, the upper region here is the solution to our inequality. So this is the solution. Now let's consider a different example. We want to solve the inequality negative 3x plus y less than 6 by graphing. So to do this, we will have to rewrite first this expression in the form y greater than or equal or less than or equal to mx plus b. So we want to write it in the form y equals mx plus b. So we do that by transposing this expression on the other side of the inequality. So again, we start with negative 3x plus y less than 6, that's a given. And then we transpose this on this other side here. So we have y on one side. So on our left side, we only have y. And then copy the inequality symbol. And then we have 3x plus 6. Okay, so we do that by adding 3x on both sides of the inequality. So now we have y and then mx plus b on the other side. Now to solve this, we will first have to graph the line y equals 3x plus 6. Now let's do that on this side here. Y is equal to 3x plus 6. And then we will get 2 points, at least 2 points on the line. This is our x value and the y value. So if we replace x here by 0, so we have, if x is 0, we have y equal to 6 because we have 3 times 0 and that becomes 0. This term here is 0, then y is 6. Then get another point, say for instance x is equal to 1. So if x is equal to 1 here, we have 3 times 1, that is 3, plus 6 is equal to 9. So we have 9. Then let's plot those 2 points. We start with 0, 6. So x is equal to, if x is equal to 0, y is 6. We have that. And then, oh, you notice that 9 is no longer here. Then we might just try x equals negative 1. Try a smaller value. So if x is equal to negative 1, okay, we have 3 times negative 1, that's negative 3, plus 6 is 3. So the other point is negative 1, 3. So negative 1, 3 is this point here. Then we can get another point, actually the x-intercept. Let's get the x-intercept, that is the value for x when y is 0. So if y is 0, we have the equality here 0 equals to 3x plus 6. Transpose that on the other side, the 6 on the other side. We have negative 6 equals 3x. And then you can divide both sides by 3. X is equal to negative 2. So we have the third point, 0, negative 2. Then next is to connect all these 3 points here. Once you connect all, okay, so to connect all the 3 points, you have to consider the inequality here. Check if it contains the equality symbol. Now, as you notice, in here, we do not have the equality symbol. That means that the line here is not included in the graph. So when you connect this with a broken line. Because you don't have the equality, you connect it with a broken line. And then you can just extend the line here. Now, the next is to identify which region satisfies this inequality here. You do that by getting a representative point. So you consider this region here or this region here. So let's just use 0, 0. That's the easiest. So we pick a point here. So for instance, this one, this is our test point. So using our test point 0, 0, we see if that satisfies the inequality. So if y is 0, and then we have x 0, so this one is 3 times 0 plus 6. Now we have 0, 6. Question is does that satisfy the inequality here? Is 0 less than 6? The answer is correct. 0 is less than 6. So therefore, this one is correct. So this one is on the region, and therefore we say that this side here is this region here is the solution, because the test point satisfies the inequality. Now let's consider a third example. Solve the inequality by graphing. So the first step is to write this in the form y on one side and then on the other side mx plus b. So we do that by rewriting the inequality. So start by writing as 2x minus 6y greater than or equal to 12. Now we want y on one side, so we have negative 6y on this side greater than or equal to, if you subtract 2x on both sides, you can transpose 2x on this side of the inequality here. So you therefore have negative 2x plus 12. Now, next is because you only want y, so we want to divide all sides by negative 6. Now you have to be careful here because you are dividing both sides by a negative number. So you divide both sides by a negative number. So because you are dividing both sides by a negative number, you make sure to change the inequality here to, or reverse the inequality. So we have less than or equal now. Can you reverse the inequality if you divide or multiply both sides of the inequality by a negative number? So with that, you now have y less than or equal to, and then you divide each term here by negative 6. So we have negative 2 divided by negative 6, that is 1/3. So you have 1/3 x. And then 12 divided by negative 6 is negative 2. So now you have the inequality y less than or equal to 1/3 x minus 2. So then the next step is to graph the line y equals 1/3 x minus 2. You do that by assigning points. You get at least 2 points, or you get the intercepts, the x and the y intercept. So this is x and this is y. So if x is 0, we know y is negative 2 because you just replace this by 0. So you have 1/3 times 0, that is just 0. So y is equal to -2. Then next you can also say, for instance, make y is equal to 0. So if y is 0, let's solve the equality here. So if y is 0, we have 1/3 x minus 2. You solve for x, transpose 2 on the other side. So 2 is equal to 1/3 x. Then you multiply both sides by 3 to cancel 1/3. So therefore, so if I multiply this by 3, I also have to do it on this side. Then the 3 cancels out. So I have x equals, oops, this is 3. This one is 3, so therefore x is equal to 6. So x is equal to 6, y is 0. Those are the intercepts. So we have this and 6, this point here. All right, now you can also assign points in between if you want to. If you are comfortable with that, we can actually let x be equal to 3. In this case, if x is equal to 3, we have 1. Okay, so 1/3 times 3 is 1, minus 2 is -1. So the third point will be 3, -1, that point there. Then we connect all these 3 points here for our line. Then to connect the points, you have to first see if there's equality here on the given. So we have equality on the given, so therefore the line is included in the graph. So we have a solid line. We use a solid line to connect all the 3 points. That's the solid line. And then you get the representative. You get the representative point to determine which region. So you want to be able to see if this region here or the region below the line is the solution. So you do that by getting a test point. Say for instance, our test point is the origin. I like to use the origin as my test point because that will just make the variables 0. So you can plug in the test point to the original inequality or to this one here, whichever works for you. So for instance here, let's try plugging into the original equation or original inequality. So if x is 0, this one will just be 0 minus 6 times 0 that is just 0. The question is 0 greater than 12? Because you have 0 here. Is that true? The answer is no. That is not true. So the test point, this is my test point, and that one does not satisfy the inequality. So therefore, the opposite region, which is this region here, the one that does not contain the test point, is the region that satisfies the inequality. So it is in the line and the region here below the line. Now for our next goal, we want to solve a linear system of inequalities by graphing. We already have discussed how to solve a linear inequalities graphically. Now, the next step is to extend this knowledge to solve an entire systems of linear inequalities graphically. Now, to do that, let's say for instance you are given a system of 2 linear inequalities. In order to solve this system graphically, all you need to do is plot both linear inequalities on the same graph. And the overlap of the 2 shaded regions will be the solution to the system. And any point in the double shaded region will satisfy both inequalities. So it is entirely possible that you have a system of linear inequalities where the shaded regions do not overlap. In this case, you say that there is no solution to the system of inequalities. For example, here, we want to find the solution graphically to the linear system of inequalities. So you're given here two inequalities. We have y less than 3x minus 2, and the other one is y less than or equal to negative x plus 5. So to solve this, we will first plot the inequality y less than 3x minus 2. So you do that by first plotting the line or graphing the line y equals 3x minus 2. And then you use a broken line or a dashed line because you don't have an equality symbol here. And then next is to identify the shaded region. You get the test point. I'd like to use always the origin as my test point. So if you plug in 0, 0 here, 0 for y and 0 for x, you have 0 less than negative 2. And we know that that is false. 0 is not less than negative 2. So therefore, this region here, or the test point, does not contain or does not satisfy the inequalities. Therefore, it's the opposite region. So it is this shaded region here that satisfies the inequality y less than 3x minus 2. Then, next is to solve or to graph this other inequality here. And let's look at the overlapping region. So, we do that by starting to plot the line y equals negative x plus 5. And once we plot that line, we will use a solid line because we have an equality symbol here. So since there is an equality symbol here, then we use a solid line, this solid line here, as the graph of y equals negative x plus 5. Then, so that's the green one, we get a representative point. Again, I would use the origin. So the origin is below this line here, and see if it satisfies the inequality. So if this is 0 and this is 0, we have 0 less than 5. So if you have 0 less than 5, that is true. So therefore, this region here that contains the test point is satisfies the inequality. So if you look at this, so you just have to shade that, and this region here is the overlapping of the two shaded regions. So this is the solution of the system of linear inequalities. Now let us consider this example here. Find the solution graphically to the system of linear equation. So to do this, we will first have to consider graphing this inequality here. Y is greater than 2x plus 1. Now you do that by graphing the line y is equal to 2x plus 1. You get representative points. So we have x and y. I like to use the intercepts as my representative point, so that I would start by letting x be equal to 0. If I have x equal to 0, then y is equal to 1. And also, if I have y equal to 0, so if y is equal to 0, then I will have to solve the equality here. 0 equals 2x plus 1. And then you have to solve for x. You can subtract both sides of the equality by negative 1, and then you end up with 2x, or negative 1 equals 2x. Then you divide both sides by 2. So that means x is negative 1/2. Now, then you plot those 2 points here. So you have 0, negative 1. And then the other point will be negative 1/2, 0. So this is the other point. Then you go back to the given And notice here that you do not have an equality symbol. So you have a strictly greater than symbol. So that means that you're going to connect the 2 points here with a broken line, with the dashed line. All right, and next is to shade the region that satisfies that inequality. So you do that by getting a representative point. As I mentioned, I always like to use the origin as my representative point. So the origin is my representative point. I'll go back, I'll plug in that 0, 0 to the given here, the given inequality here. So we have 0 less than 0 plus 1. That gives you 0 greater than, so not less than, but greater than, 0 greater than 1. Is that true? The answer is no. 0 is not greater than 1. So therefore, I would have to shade the region that does not contain, I would have to shade the region that does not contain my test point, which is this region here. Okay. Next, I will then have to consider this other inequality here. The line or the inequality y is less than or equal to negative x minus 4. I'll do the same thing. I'll graph the line y. I'll graph the line y equals negative x minus 4 first. I'll do that by assigning points. So for my x and y. So for instance, if x is 0, y is negative 4. Now if y is 0, x is equal to negative 4 as well. Okay, so you just have to input here. For instance, if x is 0, y is negative 4. If y is 0, we have to solve the equation 0 equals negative x minus 4. Just transpose x on the other side. You have x equals negative 4. So you have those 2 points. Then we'll use a different colored pen here. Now we can plot those 2 points. So we have 0, negative 4. So if x is 0, y is negative 4. It is this point here. And the other one is x is negative 4, y is 0. It is this point here. Then go back to the original given. You see that there is an equality symbol here. So we have y less than or equal to negative 3x minus 4. So therefore, we use a solid line to connect these 2 points here. So that's the solid line. So this is the line here. Then next is to shade the region that satisfies the inequality, the given inequality here, this inequality here. Now, again, I like to use the origin to do that, but to make sure to just consider this this line here, right? So it is either the region on top of that or the region below that line. So this is a reference point, the line here. Then we'll use 0, 0 as our test point. Okay, so let us evaluate this. So if y is 0, we have less than or equal to 0, negative 4. Is that true? Is 0 less than or equal to negative 4? The answer is no. 0 is not less than, so this one is wrong. 0 is not less than or equal to negative 4. 0 is greater than negative 4. So therefore, we will shade the region that does not contain, so I'll shade now the region that does not contain my test point. It is this region here. So this region here. Then you just have to consider the region that overlaps, or the region that is shaded twice. The region that is shaded twice will be the solution for our system of linear equation, and it is this region here. So that region is shaded twice, shaded with yellow and pink. So that is the solution. All the points that lie on that region is the solution for our system of linear inequalities.